A hub is a device that doesn't do anything but connect parts of a network so packets of information can travel back and forth. A hub doesn't look at the data to determine where it should go, but it will broadcast it to all the ends connected to it. It is a simple box that allows for the connection of multiple computers. It's the device that made it possible for us to use Cat5 twisted pair cabling to connect our computers together without having to run a coax cable from one computer to another in a big long bus. Computers aren't the only piece of equipment you will see connected to the hub. Printers set up on the network are oftentimes connected to a hub. Basically anything that you could network that uses a Cat5 cable, you are able to use with a hub. A hub doesn't inspect the network traffic, it simply passes every packet along from whatever port it came from to every port. In times of high traffic, this causes collisions. A few collisions aren't a problem since the computers can retransmit data if needed, but over a certain threshold they will begin to degrade in performance, such as slower speeds while working online. If you find that you don't have a connection to the network, first try unplugging and then plugging back in the Cat5 cable to the hub. If you still don't have a connection, try unplugging the hub from the network source on the wall and then plugging it back in after a few seconds. As a technology coordinator, I've found when a teacher asks for my assistance because their computer isn't working, it's not connected to the network, it won't connect to the internet, that's the very first thing I've learned to check first. Make sure that you check the cables, make sure they're both plugged in on either end. Sometimes the hub can just get kicked or knocked over, and that can cause one of the wires to loosen, which would cause the network to drop on the computer. So that's the very first thing I check. I unplug it from the hub, wait a few seconds, plug it back in. If it still doesn't work, I'll unplug the hub directly from the wall, wait a few seconds, plug it back in, and about 80% of the time that fixes the issue. So even if you're a classroom teacher and you feel helpless that your computer isn't working, if you do have a hub in your room, that would be the first thing I would check. A network switch appears nearly identical to a hub, but a switch generally contains more intelligence and a slightly higher price tag than a hub. As stated earlier, hubs are not able to determine where the data should go. However, switches have the capability of inspecting data packets as they are received, determining the source and destination device of each packet, and forwarding them appropriately. By delivering messages only to the connected device intended, a network switch conserves network bandwidth and offers generally better performance than a hub. Unlike a hub, a switch is a smart device for connecting different networks on a local area network. For example, in a local configuration of networks A, B, C, and D, A can send all day to B without interfering with the traffic between C and D. With a hub, however, all these different networks would be competing or sharing the bandwidth, which causes the slower responses and sometimes can cause the collisions. A router is a device in computer networking that forwards data packets to their destinations based on their addresses. The work a router does is called routing, which is similar to what a switch does, but a switch is a device only used to connect machines to form a local area network. A router is connected to at least two networks, commonly two LANs, or a LAN and its internet service provider's network. Routers are located at gateways, the places where two or more networks connect, and are the critical device that keeps data flowing between networks and keeps the networks connected to the internet. The way a router works is when data packets are transmitted over a network, for example the internet, they move through many routers due to passing through many networks in their journey from the source machine to the destination machine. When data is sent between locations on one network to another network, the data is always seen and directed to the correct location by the router. The router accomplishes this by using headers and forwarding tables to determine the best path for forwarding the data packets. Not all routers are created equal, since their job will differ slightly from network to network. Additionally, you may look at a piece of hardware and not even realize it is a router. What defines a router is not its shape, color, size, or manufacturer, but its job function of routing data packets between computers. A cable modem which routes data between your PC and your ISP can be considered a router. Broadband or ICS routers will look a bit different depending on the manufacturer or brand, but wired routers are generally a small box-shaped hardware device with ports on the front or back into which you plug each computer, along with a port to plug in your broadband modem. These connection ports allow the router to do its job of routing the data packets between each of the computer and the data going to and from the internet. Next, we're going to talk about the difference between wired and wireless routers. Wireless broadband routers look much the same as a wired router, with the obvious exception of the antenna on top, and the lack of cable running from the PCs to the router when it is all set up. Creating a wireless network adds a bit more security concerns as opposed to wired networks, but wireless broadband routers do have extra levels of security embedded. Along with features found in wired routers, wireless routers also provide features relevant to wireless security such as Wi-Fi protected access and wireless MAC address filtering. Additionally, most wireless routers can be configured for invisible mode so that your wireless network cannot be scanned by outside wireless clients. Wireless routers will oftentimes include Ethernet ports for Ethernet connections as well. Wired and wireless routers and the resulting network can claim pros and cons over each other, but they are somewhat equal overall in terms of function and performance. Both wired and wireless routers have high reliability and reasonably good security. Generally, going wired will be cheaper overall, but setting up the router and cabling in the computers is a bit more difficult than setting up the wireless network. Of course, mobility on a wired system is very limited, while wireless offers outstanding mobility.